Hello friends, we are now extending our discussion of AVL Search Tree to the extent that how the insertion operation is performed in an AVL Search Tree. So in this video I am going to say about the insertion procedure which is applied in the AVL Search Tree, how a new node is inserted into the AVL Search Tree and for which there are some necessary operations to be performed in some cases where the AVL Search Tree needs to be modified in some way or the other in order to retain this very property or the very characteristic of the AVL Search Tree. So we are just going to describe the scenarios. We are just going to give the overview of the scenarios in which we are going to perform some necessary operations on the AVL Search Tree in case where a new node is to be inserted into an AVL Search Tree. So an AVL Search Tree, as you know, that it is nothing but a binary search tree in which the balance factor of every node is either 0 or 1 or -1, as I have explained in one of my previous videos. If you can go to that video and see that what is an AVL search tree, then you will be able to understand that the AVL search tree is nothing but a binary search tree in which the balance factor of all the nodes of each of the nodes is either 0 or 1 or -1. So in this case, I am going to show you one pictorial demonstration of how an AVL search tree looks and what happens to the AVL search tree if one node is inserted into the AVL search tree in any position. So in that case, it warrants some sort of necessary operations to modify the AVL search tree in a fashion in order to retain the very property or the very characteristic of the AVL search tree. So let me just give you an example in order to make you understand it properly. That is, suppose this is an AVL search tree. I am just writing a very simple AVL search tree to show you how this entire thing works. That is, suppose this is 10, this is 5, this is 15, this is 12. So this is an AVL search tree because we can see that it is a binary search tree because it is partitioned in a manner which is just exactly what we should expect for a binary search tree to have values in it. So this is a binary search tree, that is 10. Then left subtree contains a value less than 10, 5, right subtree contains both values which are more than 10, and this 15 has a left subtree which has a value of 12 and which is less than 15, and right subtree is empty, and this is a leaf node, this is a pendant vertex, and there are no left and right subtrees to this node having the value 5. So this is a binary search tree, but let me see whether it is an AVL search tree. So for it to become an AVL search tree, for it to be called an AVL search tree, we have to examine the balance factors. So what is the balance factor of this node? The height of the left subtree is 1, the height of the right subtree is 1. So this height difference, that is the HTL minus HTR, which is the operation which is to be performed or the difference operation which is to be performed in order to ascertain the balance factor of each of the nodes of an AVL search tree, is nothing but which gives us a value for this 10 to be 1 minus 2, that is -1. This is 0, 0 minus 0 gives you 0, 1 minus 0 gives you 1, 0 minus 0 gives you 0. So all the balance factors which we can see from for all the nodes are either 0 or -1 or 1. So this is definitely an AVL search tree. For this AVL search tree, if we perform an insertion operation, suppose we want to insert a node which looks like, suppose if a node is going to be inserted to the left subtree part of this AVL search tree, then some situation it will become a sort of a tree with a new node inserted into it, and after that we have to reconsider or recalculate all the balance factors associated with the newly formed AVL search tree after the insertion of the particular node. In that case, if we see that if any of the nodes balance factors is being affected by the insertion process, then we have to perform some necessary operations which are some rotation operations. And I will just enumerate all those rotation operations one by one, but let me just give you an example. Suppose if we see that a value of 4 is to be inserted into this AVL search tree, what will become the nature of this AVL search tree after the insertion of the value 4? let me see, this is quite similar to the process. This is exactly rather similar to the process of insertion in a case of binary search tree, which you all know. That is, we will compare this value with this root node 10. It is less than the root node. We'll go to the left subtree, will not go to this right subtree. Then this 5 is to be compared with this 4 and see that 4 is less than 5. Then again we have to go to the left subtree and see that the left subtree is empty, and we just are going to link this 4 to this part. So 4 gets linked to this left subtree part of this 5. So the AVL search tree will now look like this, and whether we have to now consider, we have to now recalculate the values once again to see whether it is definitely, whether the AVL search tree remains an AVL search tree, or it has changed to any other form, that is, it has only become a binary search tree and not an AVL search tree after the insertion process. So after that we are going to perform the operations again, that is the difference operation again. So let me see, we are writing the modified values after the insertion process. Suppose this is a balance factor of 10 will become 2 is the height of this left subtree, 2 is the height of the right subtree. So 2 minus 2 will give you 0. So this will become 1 minus 0, it will become 1. It will become 0 because 0 minus 0 gives you 0. This will remain as 0. So I will write 0. This will remain as 1. So I will write 1. So the newly calculated balance factors are the one which I am giving a tick upon. That is this one, this one, this one, this one, and this one. So let us examine that the balance factors. We are seeing that the balance factor is 0, 1, 1, 0, 0. So these are these lie within the permissible range of the balance factors for a binary search tree to be an AVL search tree. So definitely after the insertion process, this binary search tree, this AVL search tree remains an AVL search tree, and it is not changed into any other form, that is AVL search tree remains. So in this case there is no necessary operations to be performed on this AVL search tree if after the insertion all the values are in conformity with the permissible values of the AVL search trees. Now if any other case is performed on AVL search tree in a way that some of the balance factors are affected, or at least one balance factor is affected by the insertion process, then we have to perform some necessary operations. In that case, some necessary rotations are to be performed so that we can convert the newly formed AVL search tree after the insertion process to retain the property of the AVL search tree, so that it doesn't cease to become an AVL search tree. And in that case, there are some necessary operations to be performed. I will just write it one by one. There are some operations. Suppose I will write the operations in this way. Operation can be LL rotation. This is an operation which is called the LL rotation, left rotation. This is required in case where the AVL search tree is rendered to be a search tree which ceases to become a AVL search tree. In that case, we will perform this LL rotation if the newly inserted node is on the left subtree of a node A of the AVL search tree. Suppose node A is going to be, suppose this is node A, and for this node A, this balance factor, if the balance factor of any node becomes affected or goes astray from those permissible values, then that node can be considered to be a node which we will consider as A. And suppose if after insertion procedure, suppose let us just consider to be an example where this node containing 10 has been affected, the balance factor of this 10 containing node is affected by the insertion process. In this case, we will consider that node where the balance factor is first affected from the by backtracking from the newly inserted node to the root node. While going towards the root node, in the backtracking process, if we find some node which has the balance factor affected for the first the first node which is encountered where the balance factor is affected after the insertion process is to be considered to be A, and in that case, if the newly inserted node is on the left subtree of the node A, then we are going to perform this LL rotation. So I will write this like this: newly inserted node is on the left subtree of node A. I will give you examples. I will give you proper illustrations in order to make you understand all the situations in some later videos. But in this video, I am just giving you an overview of the rotations which are necessary to perform in case where the AVL search tree has ceased to become an AVL search tree. So in this case, this is called the LL rotation, where the newly inserted node is on the left subtree of node A. In case of RR rotation, this is quite similar, just the mirror image of LL rotation. If it is that the case is newly inserted node is on the right subtree of the right subtree of node A. So there is another rotation which needs to be performed, is called the LR rotation. What is LR rotation? When the newly inserted node, I am not writing the newly inserted node every time. This newly inserted node, you consider this part to be a newly inserted node. I am just giving you dots to save some time. So this newly inserted node is on the LR rotation is on the right subtree of the left subtree of node A. And there is yet another rotation which needs to be performed in cases where the reverse thing to this previous thing happens. That is, the newly inserted node is on the left subtree of the right subtree of node A. So these are the four necessary operations which are to be performed in case of the insertion where the AVL tree is affected by some means, that is the balance factor of at least one node is affected by the insertion process. If there is no change in the permissible values for the AVL tree after the insertion process, there is no necessary operations to be performed. That is, these operations are done away with in those cases. But if there is a change in the balance factor which is outside the limit of the permissible values of the AVL search tree, we need to perform these operations in the respective cases. So this can be considered as a single rotation. So we will write these two rotations are single rotations. That is, we will describe it later on in other videos. These are single rotations. Why these are single rotations? This LL and RR are single rotations. That is, single rotations means only one step of rotation is performed, and these two are called double rotations. That is, the rotation will involve a pair of steps. So this is a two-step operation to be performed over here, and here also we will perform a two-step operation. So that will for that reason we can consider it to be double rotations, and these are considered to be single rotations, this LL and RR rotations, because this will both of these will have a one-step operation involved in them. So the one-step operation will be involved in LL rotation, That's why it is single rotation. One step operation will be performed for RR rotation. Therefore, it is a single rotation. A two-step operation is needed to be performed for this LR rotation and for this RL rotation, for which they are considered to be double rotations. And I will just give you example by example to make you understand how these things take place in respective situations in my later videos. And up to this, I will just end this video on this note, that is, we have learned how the insertion process can affect an AVL search tree, and for which sometimes there are some operations which are necessary to perform in order to ensure that the AVL search tree has not ceased to become an AVL search tree. So in that case, we end this video, and if you have any doubts and queries pertaining to this entire explanation which I have given in this video, you can well post your queries and doubts in the comment section below so that I can address them. Thanks for watching this video.